Nestled on the quiet western shore of Lake Windermere in Cumbria, Stott Park Bobbin Mill offers a rare glimpse into the heart of Britain's industrial heritage. Built in 1835, the mill was established to supply one of the most essential yet often overlooked tools of the textile trade, the humble wooden bobbin. At a time when the cotton industry in Lancashire was booming, bobbins were in constant demand for spinning and weaving, and the Lake District's abundant coppiced woodland provided the perfect source of raw material. Stott Park was one of over 100 bobbin mills operating in the area, but today it remains the only one still in working order. The mill was originally powered by a water wheel fed from a nearby tarn, later upgraded with steam power and eventually electricity, reflecting the changing technologies of the 19th and 20th centuries. At its height, the mill employed dozens of men and boys who endured long hours and often hazardous conditions, turning green timber into the smooth, durable bobbins that kept the textile industry running. The work was tough, noisy, and dangerous, but it was also vital, linking the rural landscapes of Cumbria to the great urban factories of northern England. Now preserved and managed by English Heritage, Stott Park Bobbin Mill is more than just a historic site, it is a living museum. Visitors can experience authentic demonstrations of the machinery in action, hear the rhythmic clatter of lathes and saws, and gain an appreciation for the skill and labor behind each finished bobbin. Beyond the workshops, the surrounding woodland trails recall the coppicing practices that sustained the mill for generations. Together, they tell a powerful story of industry, community, and the enduring connection between people and landscape in the Lake District.
Problem for the worker here, he's sitting here for 12 hours in a working day, that their piece of wood that they're holding on to is getting smaller and smaller. So their fingers are always getting closer to that fast sharp saw. And it's when they get down to the very last piece, that's where they would have to stay awake, because you can see just how close those fingers would get to that saw there. Now in the earlier days of the mill's history, it's what we call piecework here, so you only got paid for what you made, and they used to get paid for every gross, and a gross is just an old-fashioned way of saying 144. Victorian times, people didn't get a chance of any kind of education, so they could have a problem counting to 144. But if they could learn to count to 12 here, they're going to be all right, because he always counted up to that gross at 144 in 12s. And the way that they did it is for every 11 into their basket, they pick the 12th one up and put it to the side. And when you've got the 12 at the side, they know that they've got their 12 times 12, their gross 144. And that's when someone will take this basket upstairs to the drawing room, and then they'll start all over again with the next gross. So when these arrived at the yard, these are met by the boys that they used to bring up from the workhouses, and they were about 8 or 9 years old when they started here. And one of their first jobs is with a draw knife, they would take off strips of bark all the way up that timber. And they do that because that will speed up this wood drying out, but also just by taking the strips of bark off, it makes it a more even way for the wood to dry. That would then be stored in the barn over there for up to a year. After that year, they bring it into the mill and it gets taken to that circular saw there. And before they'll start cutting for the day, they've got to set the size that they're working on. So with their template there, they hold that against that saw. This just slides backwards and forwards to set that size. And like any sensible person that works at a circular saw, they didn't push that wood up to the saw using their hands. They always use a push stick instead. So it's just called offering the timber up to the saw by pushing it with that stick. The saw would cut through there, and that cut piece will then just fall down into the baking basket. And then they just keep cutting all the way down. Same way to count here again, for every 11 into the basket, 12 going to the side. And when the gross was ready, a man that they called the tally man would come to take the basket of gross away. And he was a tally man because each time he did take a basket of gross away, he put one notch in their tally stick for them. So keeping a tally is keeping a count. And hopefully you got your 35 to 40 notches on that stick by the end of the day, telling the boss that you've cut your 4,500 to 5,000 pieces. And then this here, it's just an on-off switch. I'm saying on-off because we have a double-sided pulley here. This side is what you call a loose spinning pulley. It's freewheeling. Nothing else will turn with that side of it. The fast pulley though, if that was to be turned by that belt, that turns this shaft and it turns the saw. So when you want to switch the machine off, they will just knock that belt off onto the loose pulley. And I'm saying that they knock off the belt, and that's where the expression of knocking off from work comes from, knocking off time. Very common way of working in Victorian mills with the line shafts and the pulleys. Okay, we're going to have a look at the steam engine now. Just need to be careful on this floor. So this is our steam engine. Steam, that's the power that it's using to work by. And this is all the way from Yorkshire, this one. It's a Bradley's of Brighouse. And when this came here in 1880, it was already second-hand. It had been working in a coal mine, a colliery, for about 35 years. But it was just pumping water out of that coal mine. Quite small steam engine in comparison to a lot of the engines that we used to use in industry. But having said that though, the flywheel, the big wheel there, that's a single cast piece of metal. That weighs about 2 tons just in itself. The same weight as 2 motor cars just in that one wheel, so quite heavy piece altogether. Its small size though made it perfect for this one mill, because this size of engine, it could keep this running every day by burning wood along with the coal in the boiler. And that's what he used here, was all the timber waste that they produced, all the shavings and the rock cuts, helped to keep this engine running every day. And the original boiler, it was a long horizontal boiler, it was a Cornish type of boiler, that was decommissioned, stopped working about 1950. We've got a new boiler, a vertical cross tube boiler, and we were here at 8 o'clock in the morning to light the fire. It takes about 2 hours to build up the steam pressure, and with the right pressure, the steam comes along that pipe that's up against the wall there. On top of that pipe, you've got your main steam valve, so when you twist that one open, that lets the steam through. The valve on top of the valve chest here, when you twist this one open, that lets the steam into the single cylinder. And inside this, you've got some large plates, piston plates, and they're being pushed backwards and forwards by the steam that's inside that cylinder. And that's why your piston arms are coming in and out, and of course the flywheel there is turning. Now you did have to have something that would govern the speed, control the speed of the flywheel, because the greater the speed of a wheel, the greater the chance that it is breaking loose or breaking apart. Very destructive when that did happen. So a clever man, James Watt, 1798, he designed the governor. That's what those 2 spinning weights are. That's the governor, that's going to govern the speed of the flywheel. And the way that this governor worked is that every time the flywheel went round once, the cogs in the cage there, underneath the governor, they were then geared to go around twice, and ascertaining this in that governor. So as the speed built up on the wheel, the cogs, the governor, and with centrifugal force, the faster that those weights spin, the further up and out those weights will move. And when those weights go up and out, they'll take that short angled arm up with them. And the action of that arm lifting twists this long thin rod. And right at the end of the rod there, it's connected to a valve. That valve will start to move down the way as the rod is twisting. And when that valve is moving down, it's shutting off some of the steam that's going to that cylinder. So you're shutting off some of that power. Take the power from the engine, of course it will then have to start to slow down. But yeah, such a quiet engine, this one.
Oh, it's lovely,
yeah,
isn't it?
beautifully
So
soporific.
Yeah.
Yeah, you get very tired when you come in here because you get that lovely little bit of extra heat and just very gentle action.
Too, don't you?
Yeah. I mean, the poor men that used to be in charge of this, they were always given a one-legged stool to sit on to make sure that they didn't fall asleep.
Oh.
Yeah. And get harsh awakening. Yeah, but beautifully quiet engine. That's the thing that surprises most people, is how quiet this engine is. There you go. So that lets you know all that steam pressure, it's all in those pipes, and that's what's operating this one engine here. And it's at the end of the day, so it wasn't as loud as it could be. So you let it run out of steam towards the end of the day. Yeah, so it's just going to be closed down, where they could start making a bobbin out of one piece of wood rather than having to make the barrel and the end separately. So making a lot more bobbins a lot quicker. And with a workforce of never more than 30 people at this one mill, they are producing up to 250,000 bobbins a week. It's a huge rate of production just with a very small workforce. And when the men and the boys worked in here, they always kept the doors and the windows wide open because they had to use the wind, the through draft to take the dust out. It did mean they're a very cold place to be working, especially in winter time. But because they made so many bobbins every day, the floor level was about this high all the way around the workshop and all of these wood shavings. And that's how they tried to keep themselves warm. They were up to their waist in their wood shavings as they're working at their machines, and then they dug out channels so they could walk through all of those shavings. And if you always walked in one of those channels, you never walked into a moving belt. Those channels always guided you around those moving belts, so aware of their own safety to a certain degree. Now, before you can turn your wood into bobbin, you've got to make the hole through the wood, smaller and bigger pieces. For the bigger pieces of wood, they were bored on this hand borer here. So there'll be a gentleman sitting sideways on like this. This will be spinning at 3,000 revolutions a minute, very sharp. And as it was spinning, the man here, he's got to get the centre of the wood onto that spinning bit. And then he's going to make the hole through in threes. So you push it on once, pull it back, let the sawdust clear, twice clear, and then 3 times all the way through, always that action. But if you hit a big knot in the wood though, good chance that wood will just stick itself onto that bit, or it will want to come straight off. A lot of them did fly off, and you can see where a lot of them also ended up. So you had to get ready to duck out the way in time on this one job. Now I'm just going to show you where they made the hole through the smaller pieces of wood, and then we will come back to the lathe. It's just that when I put this line shaft on, I can't do any talking, so it's best if I explain what that one does first. That's just down here. So this is the semi-automatic boring machine, and this is where the boys started their apprenticeship. So from the age of 8 or 9, they could be here for at least 5 years, 12 hours a day. And in the guidebook, there's a picture of a young boy standing working at this one machine. He doesn't look particularly happy, and we can probably guess why, really. Now it's automatic because it's copying the action of the man on the bench over there, but still make the hole through in threes. So when you come back with the line shaft turning, you'll see these 2 arms doing the motion, 1, 2, and 3. You just have to imagine that there was a drill bit on either end there making the hole in the wood. The semi bit is the child, because once that wood's got the hole in it, the table will pivot round. The boy's job is to take the bored wood off, throw it into his basket, and replace it with fresh wood. So for the young child here, it's just on, off, all day long, 12 hours a day. And they'll get through about 6,000 to 8,000 pieces of wood in a working day on this one machine. Very efficient machinery. Really start to see the beginning of factory work looking at machinery like this. So we'll walk back round to the roughing lathe then. Spindle will spin at 3,800 revolutions a minute, and on the end of that it's got sharp feathered mandrels. So those sharp points, they're going to mean when I push the wood onto there, they'll grab hold of the wood, and that's what's going to make the wood spin. And in a working day, a worker who turned out made about 1,200 of these in a working day. And even after the wood had been drying for about a year, it's still not completely seasoned. It was still quite wet, quite green in the centre. So when these are turned on the lathe, these were then taken upstairs to a drying room. They'd be there for about 2 to 3 weeks until they were completely dry. And then they came back downstairs and then turned on the finishing lathe. Now, we did get electric here in 1940, still the same electric motor that we're using, so I will be turning that on. There'll be a little bit of noise, and then you'll hear the sound changing as the speed is building. And when we get to the right speed, I'll be able to make the bobbins. Okay, not too bad. that's finished bobbin there. Got 3 pieces of hazel, and all of the wood that we're using at the moment is still quite green wood. It was only cut down this winter, so it's had no time at all to dry out. So you'll feel that there's quite a lot of moisture in that wood.
One here, a couple of bobbins. Yep, give them to your son.
So yeah, it's still a lot of moisture in that, so they'll still shrink a lot. But it was always very dry and very green into anything there. That's not on the surface. All of the tools on the lake here are right to that through. So throughout the day, all of the tools here had to be kept sharp. And each one of the workers that were the sheep had to learn how to sharp and set and make the winners tools. Now, finishing when because the race very dry, they have for the worker here is when that line shaft is turning, they can't switch these machines off. So while it's spinning, every 20 minutes, they're getting onto their sharpening stone, the whetstone, just getting their hands down amongst all of that just to keep on top of that edge. So they've got to make sure that nothing on their sleeve will get attached to that spindle. And if they did damage the tools, they would have to take the tools out and take them to the grindstone, regrind the metal, bring them back and reset their machine. And that could maybe take them up for a day to do something like that. And that's the day that they're not getting paid. You're only getting paid for the bobbins that you're producing. So everything that they needed was close to home. And then you had the skills and the knowledge just to manage all of those resources. Just very clever people really. Understood what they had. Certainly knew what to do with it. Very clever. So here they used to dye a lot of the wood before it left the mill, and it was always a black bobbin that you wound a white thread onto. Make sure you're definitely using white thread on your lady's wedding dress. And a bobbin like this one here, because of its shape, size and colour, it's telling you that it's got linen thread on it. So there was always a reason as to why the bobbins were the way that they were. The shape, size and colour is determined by what's going to be wound onto them. So you get a huge number of shapes and sizes, and then the more expensive the thread, the smaller the bobbin as well. I was going to see if I could find the machine silk one, but I don't know where that's gone. So as I said, it was during the Second World War this became a reserve occupation, making a lot of things for the war effort here. And they're making things like this. It's a rung for a rope ladder. And that was done for the American Liberty ships in the 1940s that they made those. Your grandson might still be coming across things like this, yes. And then with digging for victory, suddenly for a lot of fork and spade shafts in their handles, all sorts of different kinds of wooden tool handles for the land armies. And then they also got the contract for making the wooden toggles for the Navy stuffle coats as well here. So very busy times for them during the wars, really. And then after that, they had to start thinking of different things to make if they were going to survive as a business with the decline of the cotton industry in Britain. So they're making things like croquet mallet heads, spindles for chairs and staircases, yo-yos, skipping rope handles, the wooden doorknobs, all sorts of different kinds of wooden tool handles, spout bobbins, and of course those wire bobbins as well. And the last order that left this mill in 1971 was for the copper wire bobbin. And that's when 6 men were left here when it closed in 1971.
Stott Park Bobbin Mill remains one of the Lake District's most evocative reminders of the Industrial Revolution and the vital role small rural industries play in powering Britain's growth. While vast cotton mills in Lancashire drove the demand, it was in quiet corners like this that the essential tools of production were made. The mill's survival, when so many others have disappeared, offers a rare chance to witness the machinery, skills, and working conditions that sustained a once thriving trade. Today, as a carefully preserved heritage site, the mill allows visitors to experience the atmosphere of a 19th century workplace.